In this video, I shall be discussing about the fission of covalent bond and some types of organic reactions. Okay, so the first one is fission of covalent bond. Fission of covalent bond. Under this fission of covalent bond, there are two types. One is homolytic bond cleavage. Okay, so under this homolytic bond cleavage, suppose Rx, okay, in the presence of light or heat or high temperature, it gives free radicals. Okay, now here you see between these two atoms, one electrons each are shared. Okay, now in the presence of light for homolytic bond cleavage, they split equally, okay, or they split into two equal parts. Okay, so that this, see, this and this will split equally. Okay, therefore they give free radicals. The second type is heterolytic bond cleavage. Okay, so under this, let us see one example. Suppose Rx, okay, it gives ions, so R plus and X minus. It may be R minus and X plus also. Okay, now in this case, what happens? See, the shared electrons R dot and dot X. Okay, these are the shared electrons. Okay, the other electrons I'm not showing. Now these shared electrons, they go to one of the atom. Okay, in this case, both the electrons, okay, both the electron goes to X atom, and therefore the X atom will bear negative charge, that is called anion, and R will bear plus charge, that is called cation. Okay, now let us see another example for this heterolytic bond cleavage. I hope you can differentiate between the homolytic bond cleavage and heterolytic bond cleavage now, isn't it? So let us see another example for heterolytic bond cleavage. Okay, that is formation of carbocation and carb anion. So suppose R CH2Cl. Okay, so one is RCH2 plus the Cl minus, or it can also give RCH2 minus plus Cl plus. Okay, so here this plus is called carbocation. Okay, this C plus is called the carbocation. Okay, BOCATION, and this C minus is called carb anion. Okay, now comparing the carbocation and carb anion based on their stability. Okay, so 1 degree, 2 degree and 3 degree carbocation is there. Okay, 1 degree, 2 degree and 3 degree carb anion is also there. Okay, so I want you to find out the stability in which order it is, okay, for carbocation as well as carb anion. Then moving on to the types of organic reactions. So types of organic reaction. Okay, the first one, let us see substitution reaction. Okay, Okay, it is also called displacement reaction. Now in this type of reaction, what happens? The leaving group is substituted, okay, or one atom is replaced by another atom. That is called the substitution. Suppose this is the reactant and we are going to substitute Y, okay. So this is called the substituent, okay. So we're going to substitute this one in place of X. Then it will give R Y plus X, okay. Now in this substitution reaction also, okay, the substituent should be stronger than the one that is leaving, okay. Now under this substitution reaction there are three types, okay. One is nucleophilic substitution reaction. Under nucleophilic substitution reaction, okay, a nucleophile is substituted. So a nucleophile is generally represented by Nu minus N, okay. They bear negative charge, okay. So let's see one of the example for substitution reaction. Okay, now this O will attach here and this will be removed, so it will be RCH2OH, okay. So here OH is attached and Br is removed. In this case the nucleophile, again, that is going to be substituted is stronger than the leaving group. And one more thing, okay, see this minus OH or the nucleophile does not eliminate the other atoms like R or H2, okay, H atoms, because see C double bond C and C single bond C and C single bond H have stronger bond compared to CBr, okay. That's why it will replace Br. Clear? Now next one we'll go to electrophilic substitution reaction. But yeah, before that, under nucleophilic substitution reaction there are two types, that is SN1 reaction, the other one is SN2 reaction, okay. One means unimolecular, two means bimolecular. So here it depends on only on one concentration of the reactant. Here it depends on both the concentrations of the reactant. Then the next one is electrophilic substitution reaction. Electrophilic substitution reaction. In this substitution reaction, electrophile is substituted. So let us see one example, that is benzene, okay. Now this is nitration, okay, where this nitro group is added, okay. So H3 plus H2 SO4, we get this NO2 plus from this mixture, so it will give nitro, okay, nitro group or derivative of nitro compound, okay. So this is the example of electrophilic substitution reaction. Now next one, there is another example, another type, that is free radical. So for the formation of free radical, okay, here it means free radicals are substituted, okay. So free radical takes place only in the presence of light, okay. Suppose for example, in the presence of light, it gives Cl free radical plus Cl free radical, okay. Now CH4 plus Cl free radical it will give CH3 free radical, okay, plus HCl, then CH3 plus Cl dot, it will give CH3Cl. Okay, so this is an example of free radical substitution reaction. Now moving on to the next one, that is addition reaction. Now under this addition reaction, okay, in substitution we substitute, in addition we add, okay, we don't remove anything. So for example, okay, here in addition reaction there should be multiple bond, presence of multiple bond, okay. So for example, suppose this one, okay, then we are going to add X and Y, okay, this XY molecule, and it will be like this, okay. X and Y both will be substituted to both the carbon atom. Now addition reaction or addition takes place only between the carbon and carbon having double bond, okay. If suppose another group is there, okay, if it is like this, then the addition reaction will not take place between this carbon and this carbon, because between these two carbon there is only a single bond, okay. Therefore it will not take place in this type of, in these places, okay. Instead it will take place here, where between them there is double bond. Under this addition reaction there are three types, okay. So the first one is nucleophilic addition reaction. Okay, in nucleophilic addition reaction, nucleophile is added, okay. At first nucleophile will be added, then only electrophile will be added. So let us see one example, okay, plus Nu minus. Now this one will take here and this will be delocalized. So here this is E effect or electromagnetic effect, okay, is taking place. Now I want you to go and study what is electromagnetic effect, okay. Then it gives like this, this is Nu and O minus. Then this O minus will attack with another nucleophile, electrophile, okay. So it will be nucleophile O minus plus, this time it will attack with electrophile, so it will give COE, this one, okay. Now one thing, okay, see, when we attack now, it's from minus to plus, it is not from plus to minus, okay. The arrow sign should be from minus to plus. Now the next type is about rule, okay, that is Markovnikov's rule. So there is a special condition that is, okay, before that, Markovnikov's rule. Now under this Markovnikov's rule there are two types, one is Anti-Markovnikov's rule as well. So this rule is applicable for asymmetric alkenes, okay. I want you to find out what is asymmetric alkenes, okay. So according to Markovnikov's rule, say for example like this, okay. Now in the presence of HCl, this Markovnikov's rule states that the attacking reagent, okay, attacking reagent refers to the negative charge, okay. So this is H plus, this one is H plus, and the other one will be Cl minus. So what happens in this Markovnikov's rule, the negative charge or the attacking reagent will attach to the carbon atom, okay, but just wait. Okay, see, in addition reaction, the addition will take place between these two carbon, between this, I mean in this carbon and in this carbon it will be added, because between them there is double bond, but in this and this carbon it will not take place, okay, because there is no double bond. That's why between, I mean with this and with this carbon atom only it will attach. Now this chlorine ion can either attack, I mean get attached here, or it can also get attached here, isn't it? But according to Markovnikov's rule, it says that the negative or the attacking reagent will attach to the carbon atom having less number of hydrogen atom. So this has got less hydrogen atom, therefore it will not attach here, okay, and hence we will get CH3, CH, then Cl, then here CH2 again. Then automatically if I show it in one step, okay, then H plus will be attached here, okay. So this is an example of Markovnikov's rule. There is another one that is anti-Markovnikov's rule, okay. So if it is anti, okay, so let me write here, if it is anti-Markovnikov's rule, okay, anti-Markovnikov's rule. Now for anti-Markovnikov's rule, it takes place in the presence of peroxide, okay. So if there is no peroxide, it will follow Markovnikov's rule. If there is peroxide, it will follow anti-Markovnikov's rule. So in this case, the attacking reagent or the chlorine ion will attach to the carbon atom having more number of hydrogen atom. Therefore, it will attach here, and hence it will be Cl and this is H. Okay. Now the next one is electrophilic addition reaction, okay, electrophilic addition reaction. So in this case, at first electrophile is added, okay. So suppose for example plus, let us take Br 2, okay, yeah, 2. In this case, first the, okay, one will give Br plus, the other one will give Br minus. So first the electrophile will be attached, okay, so it will be C, here it is Br, okay, then this will carry plus charge, so again another Br is there, isn't it? So it will be Br minus, so it will be attacking here, okay. So we get C, this is Br, this is also Br, okay. So this is an example of electrophilic addition reaction. Now the next one is elimination reaction, okay. So substitution and elimination reaction almost resembles the same. Now elimination reaction are of three types, okay. Alpha elimination, okay, beta elimination and gamma elimination. In case of alpha elimination, okay, suppose, see, this is the, okay, suppose this is the one. Now see, this is a heteroatom, okay. So the first carbon atom that is attached to the heteroatom is named as alpha carbon atom, okay. This one is alpha carbon atom. Now on removal of the atoms, okay, for the alpha elimination, it will give carbene, okay. What happens? These two will be removed. Now next one is beta elimination. So for beta elimination, and remember one thing, that in this elimination reaction, okay, the product, this one will give carbene, this one will give alkene group generally, okay, and this one will give cyclic group. Okay, this will give a cyclic structure. So let us see an example of beta elimination. It will be like this. Okay, now here, or you can put like this. Here you see this L represents the leaving group, okay, and 1H, okay, see the first carbon atom to which the leaving group is attached is counted as alpha, and this one is as beta. Okay, so in beta elimination, it is the release of the electron, the atom or a group of atom from alpha and beta elimination. Okay, so beta carbon atom is involved, okay, for beta elimination. Next one is the gamma elimination. Let us see the example. Okay, in gamma elimination they give cyclic structure. Okay, suppose this is the one. Now in this case, okay, see, you can count from here also or from here also. Okay, suppose if I count from here, it will be alpha, beta and gamma. So there is an involvement of gamma carbon atom. Okay, then what happens, it will be like this. Okay, the bond will break to here, and here it will be extra negative charge, so the negative charge will come and attack here, and then it will release this Br. So it will become C, 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 okay. So this is how the gamma elimination reactions. Okay, now there are other few reactions. Okay, so you find out those things. So few reactions, let me show you here. Polymerization, okay, you go through those topic. Condensation reaction, isomerization reaction, and rearrangement. Okay, so in the earlier one, okay, that is the three types of reaction, I wanted you to distinguish, okay, to have a clear knowledge about those three types of reactions. So I've given already one task, that is to find out the stability of the carbocation and anion. Okay, then another one, I want you to find out, okay, see that NO, nitration. Okay, see this NO2 plus we are getting from HNO3 and H2SO4. Okay, so these two, if you add, okay, there will be other byproducts also, but then one of them we will get N2 plus. The other things also are there. Okay, now you find out by mechanism, okay, show the mechanism how we got NO2 plus. Okay.